story begins in 1909 when Karl Maybach, son of Wilhelm Maybach, the man who helped invent the modern automobile, founded Maybach Motorenbau in Friedrichshafen, Germany. Unlike his father, who built cars, Karl specialized in engines. His first big break came with Zeppelins, the luxury airships that symbolized German engineering pride in the early 20th century. Airships demanded something few engine makers could deliver at the time: a power plant that was lightweight, reliable, and capable of running for hours without failure. Maybach rose to the challenge, producing inline sixes and V12 that lifted Zeppelins like the LZ-26 and later the famous LZ-127 Graf Zeppelin. These massive flying machines weren't just national symbols, they were technical marvels, and Karl's engines sat at their heart. By World War I, Maybach designs had become critical to Germany's aviation efforts, giving the company early prestige, government contracts, and a reputation for excellence in high-performance engineering. And while aviation was the main focus, Maybach also tried its hand at the road. In the 1920s and 30s, the company built some of the most exclusive luxury cars in Germany. Models like the Maybach Zeppelin DS7 and DS8 were chauffeur-driven giants aimed at the same clientele as Rolls-Royce and Mercedes. Production numbers were small, but the cars cemented Maybach as a name associated not just with engines, but with prestige and innovation. But the age of Zeppelins and limousines wouldn't last. After the 1937 Hindenburg disaster and the rise of airplanes, airships faded from prominence. By the late 1930s, Maybach's luxury car output also wound down. When World War II began, the company shifted its focus from the skies and roads to tanks, the giants of steel that would define its wartime identity. Thus came the Maybach HL-120, a 12-liter V12 that, while modest at around 300 horsepower, became the heartbeat of Germany's most common tanks. It powered the Panzer IV, the workhorse of German armored forces, as well as the Stu-G3 assault gun vehicles produced in the thousands. While not as dramatic as the big cats, these machines were the backbone of the Wehrmacht, serving from the early Blitzkrieg campaigns through to the final defensive battles. The HL-120's reliability and mass production made it just as strategically important as the more powerful engines because it kept the bulk of Germany's armored fleet moving. Maybach post-war. When the guns of World War II fell silent, Maybach found itself in an uneasy spotlight. The same HL-230 engines that had powered Tiger and Panther tanks had also tied the company's name to Germany's war machine. The military contracts that once guaranteed prestige and profit evaporated overnight, and in their place came a harsher reality: bombed-out factories, broken reputations, and no army to sell engines to. Gone were the luxury cars, gone were the tanks. Instead, Maybach poured its engineering know-how into something far less glamorous, but far more necessary: big diesel engines for trains, ships, and heavy industry. If the wartime contracts had made Maybach a supplier of destruction, the post-war contracts would have made it a builder of recovery. The centerpiece of this rebirth was the Maybach MD diesel engine series. These weren't flashy machines. They weren't designed to roar across battlefields. Instead, they were built to pump steady power into locomotives for the Deutsche Bundesbahn, Germany's national railways, ferrying passengers and goods across rivers, and driving marine vessels through post-war Europe. The MD series didn't stop at rails. Its marine variants found homes in ferries and naval vessels, quietly expanding Maybach's reach across European waterways. Each new contract added credibility, showing governments and private operators alike that Maybach could be relied on in peace just as it had been in war. In hindsight, the MD series wasn't just a line of engines, it was Maybach's lifeline. Without it, the company might have been buried under the weight of its wartime legacy. The impact of the HL and MD. The shadow of the HL engines lingered long after 1945. On the battlefield, the HL-120, HL-210, and HL-230 had proven Maybach's skill at delivering raw horsepower. They powered everything from the dependable Panzer IV to the fearsome Tiger II, symbols of mechanical brilliance, but also of Germany's logistical nightmares: insatiable fuel demands, high maintenance, and crushing costs. By war's end, Maybach's name was inseparable from destruction, a dangerous legacy for a company trying to survive in peace. The MD diesels flipped that identity. Where the HLs were built for blitzkrieg, the MDS were built for endurance. They powered Deutsche Bundesbahn locomotives, ferries, and industrial equipment that kept post-war Europe moving. Instead of conquering territory, they carried commuters, goods, and raw materials. They lacked glamour, but they carried something far more valuable in the 1950s and 60s: reliability. Each contract proved Maybach could be trusted again, not to fuel conquest, but to power recovery. Rail operators, governments, and shipping companies leaned on the MD engines for steady performance. They weren't the most powerful machines, but they could run for hours on end without failure. That endurance, not just horsepower, turned Maybach's reputation around. By the 1960s, the strategy had worked. Maybach was no longer trapped in its wartime shadow. Its diesels had become part of Europe's everyday infrastructure, threading through railways, powering ferries, and driving factories. If the HLs embodied destructive might, the MDS embodied reconstruction. Together, they showed how a company on the brink could reinvent itself and survive. Foundation of MTU in 1969. By the late 1960s, Maybach's MD diesels had secured survival, but survival wasn't enough. The company had proven it could power railways and ferries, yet bigger ambitions loomed. That turning point came in 1969, when Maybach's engine division merged with Daimler-Benz's turbine operations. The result was MTU Friedrichshafen, Motoren- und Turbinen-Union, a new name that signaled a new identity, not just an engine builder, but a propulsion powerhouse. The merger fused decades of experience. From Maybach came piston engine mastery, refined from Zeppelins to locomotives. From Daimler came turbine technology, offering a glimpse into future propulsion systems. Together, they created a company capable of serving not one market, but many: rail, marine, defense, and industrial power. It was a leap from a niche supplier to a global contender. MTU's strategy was to build platforms, not one-offs. Its diesels and turbines could be scaled, adapted, and exported across industries. That flexibility mattered in a Cold War world where NATO allies demanded dependable military engines while civilian markets sought efficiency and durability. Governments became anchor customers, but MTU's scope now extended into commercial fleets, rail networks, and power plants. This was not a break with the past, but an evolution. Maybach's wartime HLs had shown brilliance under pressure, and its post-war MDS had proven endurance in recovery. MTU fused those lessons into a company that pointed outward, beyond Germany, toward global influence. The foundation laid in 1969 marked the moment Maybach shed its skin and re-emerged as a world leader in high-speed diesel and turbine technology. 1970s and 80s diesel engine boom. The 1970s and 80s were when MTU truly stepped out from the shadow of its Maybach past and defined itself as a global force. This wasn't about luxury cars anymore, or even about just trains and ferries. MTU became synonymous with high-speed diesel engines built for industries that demanded absolute reliability. They had locomotives crossing continents, warships patrolling seas, and tanks forming the backbone of modern armies. One of the early milestones was MTU's 331 diesel engines, which gained traction in industrial and rail applications. These diesel engines carried MTU's reputation for durability far beyond Germany. Export markets opened, and suddenly, MTU wasn't just a national name, it was a global supplier. But the company's most defining step in this era came through defense contracts. The Leopard 2 main battle tank, which entered service in the late 1970s, was powered by the MTU MB873KA501 engine. It was a 1,500 horsepower V12 twin-turbo diesel that combined compact size with enormous output. This engine became one of MTU's calling cards. Used not only by Germany, but also by NATO partners, it cemented MTU's role as a strategic defense supplier. Few engines shaped the company's future quite like this one. Decades later, the Leopard 2 and its MTU engine are still in service worldwide, a testament to the design's endurance. On the naval front, MTU's high-speed diesels were equally important. Warships, patrol boats, and submarines adopted MTU engines for their mix of speed, endurance, and fuel efficiency. These weren't just engineering wins. They were contracts that placed MTU engines at the heart of Cold War readiness. Governments trusted MTU not because the engines were the flashiest, but because they were dependable in the moments that mattered most. At the same time, MTU expanded into civilian heavy transport. Rail operators across Europe and Asia began adopting MTU power plants, attracted by their ability to handle long-haul routes without sacrificing efficiency. The export growth of this period was immense, and it's what allowed MTU to evolve from a European defense contractor into a household name in engineering circles worldwide. The 396 and 538 engines. The 1980s also saw major growth in naval propulsion. Fast attack craft, frigates, and patrol vessels relied on MTU's 396 and 538 series engines. These diesels gave navies around the world the speed and endurance needed for coastal defense and long-range missions. In a Cold War climate, where maritime strength was critical, these engines carried enormous strategic weight. MTU engines didn't just power vessels, they extended influence across oceans. Civil applications are also advanced. Railways adopted MTU's 396 series, a versatile engine family used in locomotives across Europe and Asia. These engines offered a balance of high-speed capability and fuel efficiency, allowing them to cover long distances without heavy maintenance downtime. By this point, MTU had built a reputation beyond defense. By the 1980s, the 396 had matured into a trusted workhorse for both civilian and military applications. It was a compact, high-speed V-engine that could be configured in multiple cylinder arrangements, ranging from V8 to V20, with power outputs scaling accordingly. By the 1980s, the 396 had matured into a trusted workhorse for both civilian and military applications. Rail operators adopted it for locomotives, where its balance of power and efficiency allowed long-haul travel without excessive maintenance stops. At the same time, navies deployed the 396 in patrol boats and fast attack craft, where quick response and sustained performance at sea were critical. Its adaptability across sectors showed MTU's strength in designing engines that could serve multiple masters without compromise. Running alongside the 396 was the MTU 538 series, a larger, more powerful line that pushed the limits of diesel performance in heavy-duty settings. The 538 found a natural home in naval vessels and large industrial applications where sheer horsepower and endurance mattered more than compact design. For navies, the 538 series meant warships that could travel farther and faster, with fewer refueling stops, giving them strategic flexibility in contested waters. Together, the 396 and 538 demonstrated MTU's ability to cover both ends of the spectrum: compact, efficient solutions on one side and raw, large-scale power on the other. These engines reinforced MTU's growing reputation during the Cold War era, as governments and industries alike turned to them for reliability under pressure. By the time the 1990s arrived, these series had laid the groundwork for MTU's next generation of modular, more efficient engines. The 90s were a transitional decade for MTU. The Cold War was over, military budgets were shrinking, and global industries were shifting toward efficiency and environmental responsibility. For a company that had thrived on defense and heavy industry contracts, the pressure was real: adapt or risk being sidelined. MTU's answer came in the form of engines that blend raw power with smarter, cleaner design. By the 90s, regulators and customers alike demanded more: lower fuel consumption, reduced emissions, and easier maintenance. MTU knew that the next generation of engines couldn't just be stronger. For the next generation, MTU knew it had to be smarter. That is when MTU came up with the Series 2000 and 4000. MTU Series 2000 and 4000. The Series 2000 marked MTU's move into a new era. Introduced in 1996, it was designed as a flexible, modular engine platform that could serve multiple industries instead of being tied to just one. That was a big deal because while older engines like the 396 had been workhorses, they were usually developed for specific heavy-duty uses like naval ships or locomotives. Series 2000 broke that mold. This engine was powerful enough for yachts and ferries, yet adaptable for industrial equipment, construction machinery, and smaller locomotives. This versatility made it incredibly popular among operators who wanted consistency across different types of machines. But versatility wasn't its only selling point. The Series 2000 also came with improved fuel efficiency and lower emissions, two factors that were becoming increasingly important in the 1990s as environmental standards tightened worldwide. Its modular design also meant easier maintenance and servicing, cutting downtime for operators. If Series 2000 was a breakthrough in versatility, Series 4000, launched in 1997, was a technological revolution. It became the first high-speed diesel engine to feature common rail fuel injection. This was a system that delivered fuel with unprecedented precision. For operators, that meant more power, lower fuel consumption, and dramatically reduced emissions. At a time when governments and industries were tightening environmental restrictions, this was a game changer. The Series 4000 proved you didn't have to choose between performance and compliance. It could deliver both. And because it scaled so well, it quickly found applications across industries, namely locomotives, naval ships, and even stationary power plants. The engine's reputation spread quickly. Military buyers appreciated its reliability in combat-ready vehicles and patrol boats, while civilian markets valued its efficiency and durability. The dual-market success echoed MTU's historic balance between government contracts and civilian demand. Post-Series 2000 and 4000. With the success brought to MTU by Series 2000 and 4000, the company leaned into its role as an innovator. The Series 2000 and 4000 were regularly updated with new versions that met Tier 3 and Tier 4 emission standards in the US and similar requirements in Europe. Each iteration wasn't just about staying legal. Instead, it was about keeping MTU engines attractive to operators who wanted longevity and global compliance. However, MTU also recognized that relying solely on two families of engines was insufficient to remain competitive in a rapidly evolving world. By the late 2000s and early 2010s, the company introduced the Series 1600, a smaller, versatile diesel engine line that opened doors to new industries. Unlike the larger 2000 and 4000, which were at home in ships, locomotives, and heavy defense vehicles, the 1600 was designed for construction equipment, agriculture, power generation, and lighter industrial applications. This marked an important step. MTU was no longer just a supplier to governments and heavy industry, but also a player in more everyday markets, diversifying its customer base. At the same time, MTU carried its flagship platforms into new territory. The Series 4000 gas engines arrived in the mid-2000s, a landmark moment where the proven diesel backbone was adapted for ships, ferries, and stationary power plants. These engines delivered the same reliability MTU customers expected, but with significantly lower emissions, answering the growing demand for greener propulsion. In many ways, it was a symbolic shift. Diesel had defined MTU for decades, but the future pointed toward hybridization, alternative fuels, and eventually hydrogen, with MTU positioning itself at the center of that evolution. The transition to electric. By the late 2000s, the company pushed further with hybrid power packs, combining diesel engines like the Series 2000 or 1600 with batteries and electric drives. These systems, first applied in rail and marine, represented a new philosophy. MTU wasn't just selling engines anymore, it was offering complete propulsion solutions. And looking further ahead, MTU invested in hydrogen technology, which was developing prototypes of hydrogen-fueled Series 4000 engines and fuel cell systems for stationary power. While still early stage, these projects revealed MTU's intent to shape the post-diesel future. The hybrid power pack, combining diesel engines like the Series 2000 or 1600 with batteries and electric drives, was one of the clearest examples. Rail operators could now switch seamlessly between electric and diesel modes, saving fuel and reducing emissions. In marine applications, hybrid solutions offered quieter operation in ports and cleaner efficiency over long distances. For a company once defined by raw horsepower, this was a striking evolution. MTU was selling propulsion concepts, not just engines. These changes didn't happen in isolation. In 2011, Rolls-Royce and Daimler jointly acquired Tognum AG, the parent company of MTU. By 2014, MTU was fully integrated into Rolls-Royce Power Systems AG. This gave MTU something it had lacked before: the resources and global footprint of Rolls-Royce, paired with the credibility of a name long associated with high-end engineering. For Rolls-Royce, the acquisition gave access to proven diesel and gas engine technologies for industrial and defense markets. Under Rolls-Royce, MTU pushed deeper into future fuels and net-zero technologies. Prototypes of hydrogen-fueled Series 4000 engines were developed for stationary power generation. Alongside this, MTU unveiled fuel cell systems designed for data centers, hospitals, and critical infrastructure. More than a century after Wilhelm Maybach first put his name on an engine, the legacy lives on. MTU's story spans luxury cars, war machines, industrial workhorses, and now clean energy solutions, a rare arc of reinvention. It is no longer just an engine maker, it's a bridge between the industrial past and a cleaner, more efficient future. The roar of its engines, whether in a tank, a ship, or a power plant, tells the story of how engineering, necessity, and vision can carry a company through wars, recoveries, and revolutions in technology. And if history is any guide, MTU's engines will keep driving industries forward for decades to come.